Here's some problems we can try and solve together. Let's go back and just say where they put the letter A here, that's the side they want. We'll solve all three, but to answer a question for a test, they're going to ask you about one side typically. Here's the side they want to know on this one. It's their unknown. They put a variable here. Let's make sure we can identify what our work is ahead of us. So on these three even numbered ones, I'm solving for the length of one of the legs of the isosceles right triangle. And on these three on the left, I'm solving for the hypotenuse. So knowing that it goes, let's do this, leg, 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 square root 2. I first see a leg at 9 right here. That means my other leg is 9, and that means my hypotenuse has to be 9 square root of 2. And that was the side they wanted. Try it on the next one. I know my ratio of my sides is the legs are the exact same, and my hypotenuse is a little bit bigger. Therefore, I see one leg is 5 square root 2. That means the other leg has to be 5 square root 2. And it means my final answer here has to be 5 square root of 2 to represent the leg times the square root of 2. If I put that in calculator, it's going to give me the answer 10. Since I wanted to know the hypotenuse, that was the ratio of the side. Here's the final length, 100% credit. Here's one more right here. Leg, 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 square root 2. I can use this same proportion because these are all 45, 45, 90. This leg is 2 square root of 3. Remember, the uniqueness of this process is you're given a triangle with only one length, but you can solve for all three. This has to match it exactly. And the side they want you to solve for, the hypotenuse, you would take that leg of 2 square root 3, multiply it times the square root of 2, and we discussed a minute ago what's outside the radical stays outside, what's inside gets multiplied together. 3 times 2 is 6. Your final answer for that one is 2 times the square root of 6. I got a little overzealous in that blue line. Let me just take a little bit of that out, look neater. That's 3 where you had to solve for the hypotenuse. Now let's use the same ratio of leg, 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 square root 2. On these three problems, note on these they're giving us the hypotenuse length. Okay, I have some white out drawing where I made that little mistake there, but let's go back here. If we know it's leg times the square root of 2 to represent the hypotenuse, and our hypotenuse is 2 times the square root of 2, it's logical that each of these legs are 2, and you're done. Since I wanted leg K, we could have said this was leg K, and we could say this is the answer for this problem right here. For these, I showed you in the first part of the video how to rationalize. I said all you do is take the hypotenuse times square root of 2 over 2, and if you can reduce, because 6 is divided by 2, your final answer would be 3 square root of 2. If one leg is 3 square root of 2, then the other leg is also. So we'll say it was this one right here, but you can see the work all happened here. To get the answers, the legs are the same. Same here. Let's take the shortcut. Remember, square root of 2 over 2 is key. So let's go 5 square root of 6 times square root of 2 over 2. That's going to equal 5 times the square root of 12 over 2. Okay, we actually could do our factor tree for 12. Let me do it over here. How we learned back in Unit 3 in the fall. And we could take prime numbers into 12. 2 goes into 12 gives me 6. 2 goes into 6 gives me 3. 3 goes into 3 till we get to 1. Simplest radical form for square root of 12 would be 2 times the square root of 3. 1, 2 would come out here. We said when 2 become 1, they move out. But if we're left with one number by itself, it has to stay inside the radical. The 3 would stay inside, and you'd have 2 square roots of 3. So that means right here, I'm going to have a 5 still here, a 2 is going to come out, a square root of 3 is going to be here, and I have this 2 in the denominator. And I'm always allowed to simplify fractions. These 2's cancel, and I end up with 5 square roots of 3 for this leg, and it also means this leg, when simplified, was equal to 5 square roots of 3. So go back and highlight. If you want to say this is P, this is the other leg. That's how you would do that one.